So the second theme is, what are the effects of climate change? How has climate change affected people? How has climate change affected all of us living on this planet? We've seen the photos and probably many of you have seen the glaciers and the sea rise levels that are affecting the Arctic, and climate change is moving twice as fast in the Arctic as it is in other parts of the world. So that we're losing glaciers, we're losing ice caps at a very high rate, and polar bears are being affected by this problem. We also know that climate change is breaking down our ecosystems, and this includes people living subsistence pastoral or herding cultures, farming cultures, fishing cultures. That the sea level rise is affecting right now up to 40 countries around the world, especially, and we're going to be talking later this morning about what the sea level rise is doing in particular in the South Pacific. There are glaciers around the world that are rapidly losing their ice and are melting. This is happening in a big way in the Himalayas, in the Andes, I was fortunate enough to climb Mount Kilimanjaro in the 1970s, and they had a glacier on the top of Mount Kilimanjaro, and people tell me it's almost all gone now. So what this is doing, of course, in Asia, these glaciers are hugely important as rivers flow down from the Himalayas into the Ganges and the Mekong, and so we're seeing tremendous levels of flooding, which will only intensify in the next few years. And so what does this mean for migration, human migration? And this is the second major theme, is that what is the effects of climate change on people that can no longer manage their livelihoods in the places where they are living and working. Many of these people are moving. UNHCR, the United Nations High Commission for Refugees, estimates that right now there are approximately 22.5 million people a year that have been forced to move because of climate change. It's estimated that movement around the world right now, about between 10 to 15% of migration is due to climate change. Most of the people that are moving are staying in the country, moving to the cities, moving elsewhere, moving with family, but many of them are becoming refugees. So, for example, the scenes that we have seen for the last couple of years of refugees moving into Europe, most of those refugees are moving because they're fleeing war. They're fleeing the war in Syria. They're fleeing the war in Afghanistan. They're fleeing bad government in Eritrea, or forced military service in Eritrea. They're fleeing war and Al-Shabaab in Somalia. But there are other refugees that we see coming from West Africa, from the Sahel, which is south of the Sahara. It's a little belt south of the Sahara that goes all the way across Africa. And many of the people coming from West Africa are can no longer farm their land, can no longer support themselves and their families. They're moving into Europe to try to make some money. So this brings us to the third theme today, which we're going to be talking about more, I think, later this afternoon, which is, who are refugees? Right now, the Geneva Convention defines refugees as somebody who is fleeing a situation where they are at risk of persecution, or have already been persecuted against, or they're fleeing a war situation, they're fleeing conflict, or they are fleeing because there are they could be locked up or killed for political reasons. So they do not necessarily cover climate refugees. So climate refugees, we use the term climate refugees, or migrants, environmental migrants, or climate migrants. According to the Geneva Convention, climate refugees aren't really refugees, even though they are, in the sense that they are being forced to move. And how do we define, for example, the situation in the South Pacific, a country like the Maldives that has a lot of little islands? When an island becomes inundated and people are forced to flee, those people are stateless. That's a definition. That's a definition of what a refugee is. So these are some things that we're going to be talking about later on in the afternoon, really important, and I think fit in really well with this theme of environmental ethics. So I'll hand it back to you, Danny. Thank you.
So hopefully everybody who has free time between now and 4:30 is motivated to spend as much time as you can here. So the first formal presentation of the day is student Taylor Blair. Come on up, Taylor, and just open up your talk. Taylor is a student in integrated studies, and if you're not aware of this, and many of you might be entry-level students here, if you can't decide on one major, what you can do is become a student in integrated studies and focus on two different emphases rather than one major, which is what Taylor is doing with emphases in environmental studies and social studies. Yeah. And as a student in integrated studies, the capstone project is to write a thesis that combines your two areas of emphasis. And that's what we'll be hearing from Taylor today. His capstone project is a project on climate refugees done under the guidance of Professor Alan Clark and who else? Thomas Bretz. Yeah. Okay. Excellent. Okay. I'll take it away, Taylor.
Thank you, Dr. Horns. Okay, so like Dr. Horns mentioned, I'm a integrated studies major. My emphasis is in environmental studies and social sciences. So naturally, climate refugees has been a perfect way to integrate to those emphases. And that's actually what I'm doing my senior thesis on right now, is on climate refugees. So I've been reading a lot about it, and I'm really excited to talk to you guys about what I've been learning about. Okay, so for my presentation, I wanted to be able to answer three primary questions. Question number one is, how will climate change affect world geography and climate systems? Question number two, who will be affected, and how will this impact them? And then the final question is, how can the world respond? So to be able to answer those questions, I divided my presentation up into three topics. So the first section is the geophysical effects of climate change. So this is more of like the hard science behind climate change. And then the second section will be the at-risk human populations. So these are the regions that hold human populations and the demographics that will be most adversely affected by climate change. And this is actually what I'm most interested in is the humans that will be affected by this. And then the third section will be mitigation and adaptation. So I'm just going to be briefly talking about the current laws related to climate change and policies. Okay, so first section, geophysical changes. Okay, so this graph shows atmospheric CO2 levels from 2005 till present, so for about 12 years. As you can see, it's been steadily increasing. The cause behind this is directly related to human activities, primarily burning fossil fuels. And this increase of CO2 levels that we're pumping into the atmosphere is contributing to the greenhouse effect. So it's effectively keeping the Earth warmer. And this actually isn't all human caused. CO2 levels have fluctuated historically, as you can see in this graph. So over thousands of years, it's gone up and down. But most recently, in the recent past, CO2 levels have increased very dramatically. And that's mostly due to human activity from the industrial revolution. Okay, so average temperatures have increased by about 1 degree Celsius since reliable record keeping began in 1880, as you can see from the graph. And this information was taken off of NASA's climate change website. And the current warming is occurring roughly 10 times faster than the average rate of ice age recovery warming. So we're speeding up the process. Okay, so one of these effects is ice melt, and this is occurring in different ways. First, I want to talk about Greenland. Greenland's contribution to global sea level rise is the largest and increases every decade. Arctic temperatures have been increasing twice the global rate since 1980, and I think Dr. Sutter mentioned that when he was talking. Also, smaller mountain glaciers and ice fields are shrinking at an accelerated rate. And the graphic on the right shows the retreat of ice on the Muir Glacier in Alaska, as you can see that. So there's a picture taken in 1941 and then taken again from the same location in 2004. That's just showing how much the ice is melting in Alaska. And that's not, there's many other examples that are similar to that as well. Okay, so one of these effects is permafrost melt. This is primarily just seen in Arctic, and this happens because warmer temperatures cause the ice in the ground to melt, prompting geologic shifts in the landscape. Coastal areas are becoming more susceptible to erosion because of this. Additionally, there are 5 indigenous communities in Alaska that have experienced increased erosion, loss of sea ice cover, and flooding over the past decades. These settlements have undertaken planning for relocation and have received government funding for these processes. Okay, so another effect of climate change is desertification. And so desertification is mostly occurring in inland continental areas. Normally, desertification is caused by human-related activity, such as livestock overgrazing and overuse of water. The reason that this is related directly to climate change is that increasing temperatures are projected to amplify or worsen the desertification process. And the severity and scale of desertification will vary across continents, but Africa's current climate and geographic features make it particularly vulnerable. Okay, so on to sea level rise. And sea level rise is actually what I've been studying the most. That's kind of what I'm mostly a nerd about, and that's what we're going to be talking a lot about today. So most of my presentation will be focused just on this and how it affects humans. So obviously, these effects will be experienced in low-lying coastal areas, particularly river deltas and islands. And here's a quote from NASA.gov that talks about this. NASA says that global sea level rose about 17 centimeters, which is about 6.7 inches, during the last century. The rate in the last decade, however, is nearly double that of the last century. So we can see an upward trend in sea level rise. It's increasing more and more as time goes on, and quicker too. So there's three primary contributors to sea level rise. I'm going to briefly just talk about those. The first one, and the most significant one, is land ice melt, which I've already talked about a little bit. This just occurs when ice is melting upon the land, then it drains into the oceans. Pretty simple, and it's pretty easy. It's been easier to see that. The second cause, which is a little more complex, and it's not as easily noticeable, is thermal expansion. And thermal expansion happens when water temperatures increase. It causes the volume to increase as well. And it's estimated that the amount of sea level rise due to this cause, thermal expansion, has been 0.4 to 0.8 millimeters per year from 1971 to 2010. So it's significantly contributing to sea level rise. And the last contributor is groundwater extraction. And so groundwater is being extracted much faster than it is being replenished. This water is removed from the ground for human-related uses, then eventually precipitated or drained back into the oceans. So this is water that humans are just taking out the ground. It doesn't go back into the ground. It just mostly goes back into the oceans, which is also increasing the sea level. Okay, here's a little graph that just shows the sea level rise from 1993 till now. It's risen about 80 millimeters during the past 2 decades, and the average rate of increase since 1993 has been 3.4 millimeters per year. Okay, so on to the human side of things. Which demographics will be harmed the most? The adverse effects upon human populations has been one of the primary focuses of my research so far, as I was saying. I'm going to discuss 3 case studies that show the effects of sea level rise on human populations. The 3 areas, or the 3 regions I wanted to show, are the Maldives, Bangladesh, and Florida. Each of these areas are especially threatened by sea level rise, and that's why I chose them. So before I get into that, I'm going to talk a little bit about some of the global predictions. So there is very strong agreement that sea level will rise an additional 1 to 4 feet by the year 2100. A half-meter sea level change implies a likely displacing of 72 million people, and that's based on population predictions for the year 2100. That's a lot of people, and that's pretty likely to happen. Half a meter sea level rise is, they're pretty confident that will happen, even if we mitigate. So that's a lot of people that will be displaced. A more severe estimate is that a 2-meter sea level increase will likely displace 187 million people by the year 2100. And that could happen as well. It just kind of depends on what we do, or what the world does to mitigate and adapt to that. Okay, so the first case study is the Maldives. I'll tell you a little bit about it. The Maldives is a small island nation in the Indian Ocean. It's comprised of about 200 inhabited islands and about 1,000 uninhabited islands. The series of small islands supports about 300,000 people. The average height above sea level for the islands is only 1.5 meters above sea level. Sections of the island will become uninhabitable even before sea level rise due to increased frequency and intensity of storm-caused flooding. Realizing these risks, their government, the Maldives government, has been petitioning the United Nations since the 1980s for reduction of global greenhouse gas emissions. So this is a nation they're aware of it. They're looking for ways to try to save their islands. Another case study is Bangladesh. Bangladesh is a coastal river delta nation that borders India. It supports a very large population of about 160 million people. So that's huge. That's a lot of people packed into one country. It's very densely populated. It has more than 1,000 inhabitants per square kilometer, and these inhabitants also live really close to sea level. 500,000 people are displaced each year from flooding in the Ganges Brahmaputra Delta, which is the main river that comes down from the Himalayas into Bangladesh. So they're pretty well acquainted with climate-related effects. The country has endured major problems of seawater inundation, which threatens vital rice production. So it's not just affecting the humans themselves, but it's also negatively affecting their agriculture, their ability to feed themselves. Okay, so the last case study is Florida. I wanted to choose this one because it's more close to home for a lot of us. It's more easy for us to relate to it. This is actually kind of special to me because I actually created that graphic using ArcMap, using GIS software. I did this last semester. The goal for this project was to be able to show how many people in Florida will be affected by a 1 meter level or 1 meter increase in sea level. So I was able to do that using ArcMap. So as you can see on the graph, the red area are populations or there's elevation less than 1 meter above sea level. Orange is elevations between 1 and 2 meters. The yellow is elevations between 2 and 3, and then the green is elevations above 3 meters, which is generally the safe zone. As you can see here, there are almost 4 million people who live in Florida right now that are at risk for sea level rise. Okay. So on to my last section, which is mitigation and adaptation. So the examples shown in the presentation so far represent potential problems that will be felt globally on a larger scale in the future. The United Nations Secretary General considers credible estimations of predicted climate refugees by 2050 to be between 50 million and 350 million. So that's a lot. That's a lot more refugees expected than there are currently right now. And that's only 35 years away. So what can be done to help solve this problem? Like any big problem, there's like any big event, there's things that get in the way. And I'll talk a little bit about these. So there is a strong body of evidence from development studies and political science that violent conflict undermines human security and the capacity of individuals, communities, and states to cope with these changes. These observations suggest with high confidence that where violent conflict emerges and persists, the capacity to adapt to climate change is reduced for the affected populations. Here's another quote. Armed conflict disrupts markets and destroys infrastructure, limits education, and the development of human capital, causes death and injury to workers, and decreases the ability of individuals, communities, and the state to secure credit. Conflict thus creates poverty and constrains livelihoods that, in turn, increases vulnerability to the impacts of climate change. So there's been studies, to basically summarize what I just said, like there's been studies that have shown that the more violence is happening in these regions, the less likely these populations are going to be able to protect themselves from climate change. So I'll talk a little bit about the current framework and laws. Climate change refugees are currently not recognized under international law. This may change as more people are displaced due to climate change related reasons. Dr. Sutter talked a little bit about this earlier. The reason for this is that status has not been granted because it's difficult to distinguish climate change related factors between other environmental factors. It's hard to decide who qualifies as a climate refugee or not. However, climate displaced persons may be assisted and protected through other laws. Excuse me. International human rights law does say that governments have the responsibility to protect individuals within their jurisdiction. So even though climate refugees aren't technically recognized yet, there may be other ways that these displaced persons can receive help from their own government as well as international governments. Okay. So I want to talk a little bit about some of the proposed strategies to work for climate refugees. Responding to climate change will involve a two-tiered approach. First, mitigation, which is reducing the flow of greenhouse gases into the atmosphere. So that's just actively trying to stop the things that are contributing to climate change. And then number two, adaptation, which is learning to live with and adapt to the climate change that's already been set in motion. And that's something that I think we need to recognize, that this phenomenon of climate change is already happening. Even if we were to completely just stop greenhouse gas emissions, the global temperatures would still continue to rise for a long time because of what we've already been doing to the climate. NASA's climate website also recommends that the solution will require both a globally coordinated response, such as international policies and agreements between countries, a push to cleaner forms of energy, and local efforts on the city and regional level. So NASA believes that it'll take an international effort as well as a local effort to solve some of these problems. To accommodate the expected refugees, international migration would work better if it were legal and monitored rather than illegal and out of control. There is robust evidence that mutual integration and co-production of local and traditional and scientific knowledge increase adaptive capacity and reduce vulnerability. So basically what that means is that science-based approaches combined with traditional knowledge will work better, or will work best to protect communities. Adaptation methods for sea level rise will vary, but some of them may include options such as land claim, beach and dune nourishment, the construction of artificial dunes and hard structures such as seawalls and storm surge barriers, or removing invasive and restoring native species. Okay, so that's the end. That's all I have to present. Thank you. Do we have time for questions? Okay. Oh, thank you. Yeah.
I appreciated your very fine presentation, and your slides were terrific. But just to put a little specifics on what you said about Florida, we saw the areas that are at risk, but Miami actually has budgeted and is working with $400 billion right now to do two things. One, to raise their roads, and also to improve their system, because what's happening, they have these tides when it gets flooded. So it's not just in the next 20, 30, 40 years. It's a problem right now, and it's happening right now, even in Florida.
Yeah, thank you for pointing that out. That's one thing that maybe I didn't talk about as much, is that a lot of these problems are already being felt and seen throughout the world. And a lot of my estimates too about the numbers of displaced people, those numbers are based off of predictions that don't include any buildup of barriers, any policies to protect people. That's just saying, like, these are how many people live in this area, and if we don't do anything, this is how many people will be displaced. So, thank you, Dave. Yes.
You mentioned, not sure this is working,
I can hear you.
that, regardless of what we do, even if we're able to cut off completely, like the pollution things that we're going through right now, that the sea levels are still going to continue to rise. And historically, that's been happening for millions of years. Sea levels have risen and fallen. I mean, Utah used to be covered in a giant lake. So are we certain that even if we were able to negate all pollution, that would actually stop the problem?
Yeah, I think you raised a good point. One of the graphs I showed that CO2 levels have increased or have gone up and down, and we also know that sea level does go up and down as well. Historically, it may not have been a problem because indigenous communities are good at adapting to climate change. The last time that sea level has risen significantly has been thousands of years ago, when the world was a lot less populated. But now there's over 7 billion people on the planet. Hundreds of millions of these people are close to sea level, basically locked in place. They're not really able to move as freely as humans were thousands of years ago. So you're right. It's still, whether it's human caused or not, it's sea level will rise naturally, but it's still a human rights issue because it's still going to displace potentially millions of people. Does that answer your question? Okay, thank you.
Thank you, Taylor.
Okay, wonderful.
And a little follow-up to that question. One interpretation of that last question was, sea levels rise naturally. Why are we ascribing this sea level rise to human activities? And a short answer to that is there's nothing in the geologic record that would indicate sea level rise as rapid as what we're experiencing now. It hasn't happened naturally. It just hasn't. Before you leave, let me point out on your way out the door, go to the left. There's a table with some literature that combines both of the topics today. There's literature from the Ethics Center here at UVU. There's also literature from the Citizens Climate Lobby. We'll hear from them a little bit later. But the Citizens Climate Lobby is a nonpartisan organization that seeks to encourage governments to react to climate change and to help mitigate climate change. And we'll kick off again at the top of the hour.